Hello viewers, welcome to this particular lecture on microbiology. In this particular lecture, I shall be discussing the different aspects of HIV variability, detection of human immunodeficiency virus, and also management of this particular infection or disease of AIDS. Now to start with, we must understand the quantum of infection. Each time when a particular cell is infected, up to 10 to the power 10 such virions can be released. So you can very well understand the huge amount of virus particles that is being released into the body after the infection at every instance. And that takes no time basically to win over the defense mechanism of the human body. And at the same time, they are generating or fiddling with huge number of nucleotide. So when they are fiddling with that nucleotide, there is always possibility of recombination. And when there is recombination, they can create new varieties. So there lies the main problem of HIV infection. Let us consider the typical way by which this HIV will replicate. You know, they normally search for the lymphocytes. They search for the CCR5 and the CD4 receptor, bind with the receptor, that is, they bind with the cell membrane, and they release all those enzymes and the RNA. So the RNA and the enzymes of reverse transcriptase or integrase or protease are released inside. And this particular reverse transcriptase will be active and it will produce the DNA from the RNA, and with the help of integrase enzyme, the DNA will be integrating with the host DNA, and thereby now the host DNA will be participating in the production of the viral RNA, and this viral RNA will now translate to produce viral protein, early and late expressing protein, and these proteins will actually conjugate with each other and they will produce the final viral particle, and this viral particle will bud away, or it is budded off from the host cell, and in this way the complete virus particle is free now to attack another cell. So this is the normal pattern, and based on this there has been some specific protein denoted like the GAG protein, Pol protein, TAT protein, ENV protein, REV protein, all these. Out of this ENV protein with this 1800 base pair releasing those ENV protein is most important because it produces the GP160, which is binding with the host cell. Based on this particular ENV protein characterization, we have actually classified the HIV-1 into at least 3 major and 1 minor group, and they are the group M, N and O and the P. And the M is also further subdivided into A, B, C, D, F, G, H, J and K, and further other recombinant forms. So I tell you, this number might increase also. Now, global distribution of these groups of HIV-1, you can see certain continents will show specifically the presence of a particular substrain. Like the entire North America is showing B, or part of South America, it is showing this particular strain which is B and BF recombinant. So BF recombinant is here. Entire Africa, which is considered to be the origin of this particular HIV, is showing C, then F, and then also there may be other types like the particular unexplained. That means this area is not properly known. The country of India typically is having the C, and again Australia is having the same B as that of North America. So this global distribution pattern of HIV-1 indicate that certain continents are dedicated for particular HIV, and they are also developing into new strains through recombination. So this is more or less the pattern, but of course with time this pattern might change with the emergence of new data. Now coming to the different clan, basically this is HIV clan, and you can see here this is the HIV-1M group. So broadly this is the largest group, followed by this N, which is a sub branch here, followed by this O, and you can see clearly they have all arisen from a separate locus from that of HIV-2. and their close groups are actually placed in a different clan, and they are the SIV. So basically this group represent the HIV1 from chimpanzee. CPZ is chimpanzee, represent the largest clan, and this SIV AGM is the second largest, and HIV2 is the third largest clan. But we must consider this: SIV or simian immunodeficiency virus is very close to HIV, but they are representing a separate group altogether. So when we consider this SIV, we should also have some idea of how it develops. We can understand that this particular SIV actually originate from monkey, from the green monkey or the sooty mongobi, and they have actually stabilized in the chimpanzee. So from this particular chimpanzee, that is SIV CPZ, the current subgroups of MNO have been created in human. So we actually in human, the HIV1 comes from the SIV CPZ. That has been proved genetically. But considering the SIV group itself, it can be classified into two major groups and 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 minor groups. So these two major groups obviously will be representing the HIV1, or it corresponds to HIV1, and the second one is corresponding to HIV2. So this is the pattern of phylogeny in the SIV and HIV. And that way we can clearly state that the HIV in human is coming from monkey or chimpanzee. Now, after the development of the disease, we have also seen that the different races or ethnicity, they also show pattern or differential infection. Like you see here, in Latinos or Hispanic, 21% infection have been detected, whereas in white-skinned people, 31% infection. In African Americans, there may be 44% infection, whereas the Asians represent only 2%, and it is very less in Hawaii and Alaska. So that way we can clearly say that these two groups are relatively safe. But how this particular trend develops? It definitely develops through uncontrolled sex, or maybe some other habit by which this HIV is spreading with human civilization. So basically that growth of the civilization, development of the civilization is also helping in the development of this particular disease. That we must understand from this particular slide. Now let us come to the various ways of detecting this particular disease. Now the ideal way is to detect by ELISA or enzyme linked immunosorbent assay. There can be two ways. There is the direct ELISA and the indirect ELISA. What is the difference? In direct ELISA, what is done is the antibody is absorbed to which the antigen is binding, and then to which the enzyme linked or the dye linked antibody is binding, and thereby the color develops. In case of indirect ELISA, what we do is, here the antigen is first bound and then the antiserum is added. So the antibody from the patient is added, to which the secondary antibody is binding, and the color develops after this. So in case of direct ELISA, we are immobilizing the antibody. In case of indirect ELISA, we are immobilizing the antigen. But this particular test all the time will not detect. Why I tell you? Because the serum half-life of this particular antigen may be very low, the titer value may be very low, so the antibody will not detect. Or in the other way, the antibody may be very low, so the antigen may not detect. So what we do is, the ideal way to detect this particular disease is the Western blot, by which we can separate this particular protein through SDS page and then develop it through the attachment of primary or secondary antibody. And when we do that, we can also have some kits by which we can reduce this particular timing. But this particular detection by Western blot is an ideal method to detect HIV when ELISA is failing basically. So this way of detecting HIV by this particular Western blot is an ideal method to detect HIV. Now coming to the present day research to treat this particular disease. This particular disease actually is caused by HIV that has been denoted way back in 83, and then only within 2 to 3 years series of drugs have been developed, and these particular drugs are actually preventing the replication of this virus. So the treatment started immediately after discovery, and the present day research will include development of vaccine, which may be very important, which can be protein, which can be DNA. Secondly, it can be production of some microbiocide. What is that? Any microbe which will prevent the growth of HIV. Thirdly, it can be stem cell therapy. Now it has been proved that if a infected person is treated with stem cell from an uninfected person, the quantum of the disease may be checked or reduced. And finally, there may be very easy immunomoderator or immunomodulator drug which will fiddle with the immune system and will increase the longevity. But as on date, the most important phenomenon which is used to treat HIV is the HAART, and this particular movement was initiated, that is highly active antiretroviral therapy. It was initiated in Vancouver in Canada in 1996, and this particular method actually is following certain specific pattern where we follow a specific pattern, meaning if the ELISA is confirming HIV infection, the symptomatic patients will be initiated with HAART, and then the asymptomatic patients will be randomly treated or examined with the lymphocyte count, and there the HAART will be initiated only when the symptoms appear. So the most important thing is to categorize the patient, and we will understand which particular drug is to be given, and then only that drug is given. So it is more or less a disciplined way of treating rather than throwing stones into the pond. Got it? So this particular HAART therapy is aimed towards certain specific objectives. They are, say for example, the CD4 cells or the lymphocyte counts go down. So with this therapy, the CD4 cells must go up. At the same time, the CD8 cells must go up. And there must be some added symptoms which has to be reduced. And there must be the distortion reduction. And finally, the immunity should be protected and should be continued for a prolonged period so that the person is not showing severe immune deficiency. That is our aim basically in HAART.
Sir, why is vaccination not considered in the HAART?
You see, vaccination is a proposition, definitely. But first of all, you must understand that the topology of that particular virus is changing. So when you are applying a vaccine, at one point of time, that vaccine will not work, number one. Number two, the DNA vaccine is being developed, but it has not yet been proved to be safe in human trial. So naturally, vaccination cannot be a proposition clearly stated in HAART. Got it? Now, let us consider the different milestones which we have achieved in HIV control. Though this particular milestone is still 2002, maybe after that some other discoveries have been made. So in 1982, this particular AIDS was reported, and this particular antiretroviral drug was given in 87. I told you it started immediately, and then this becomes the number one cause of death in 1992. It becomes a detrimental disease, and the first protease inhibitor was given in 1995, and then this particular non-nucleoside reverse transcriptase inhibitor was approved in 1996, and this particular killing aspects of HIV in African Americans was detected in 2000. That is the major infected race. And finally, HAART was initiated and it reduced and the number of deaths came down. So beyond 2003, definitely the situation is much better in the developed world. But the condition has become worse in the developing world because of the fact that we are ignorant of this disease and we try to conceal facts. Because you see, the moment if the person declares that I am having HIV, immediately that person will be boycotted by the entire society. So there lies the problem. HIV now is becoming more a social problem than a medical problem. So this particular problem will result in more spreading of the disease, more killing of the people. Right. Now let us come to the typical regimen that is involved in HAART. and they are basically based on two specific line. One is the preferred one is the alternative one. In the preferred one, they are giving this non-nucleoside reverse transcriptase inhibitor. Along with that, they are also giving other drugs. But in case of alternative therapy, they are giving mostly protease inhibitor drugs, where the supporting drugs will be NRTI or NNRTI. So right now, HART also says that this particular disease cannot be treated with one drug, and the specific line may be they are treating it with abacavir, lamivudine and zidovudine. So one drug is not really suitable to treat this particular disease. This much at least we have understood. Now let us discuss the different drugs that can be used to prevent this particular virus. The first group of drug is actually the entry inhibitor. That means you are closing the gate, you are not allowing the virus to penetrate into the cell. And that include the attachment inhibitor, the V3 loop inhibitors, the helical domain targets inhibitor and the chemokine receptor inhibitor. All these target receptors are blocked so that the virus cannot enter. And this particular drug, which is actually called enfuvirtide, this drug is a cyclic hydrocarbon which is used as a particular receptor inhibitor, where you can see this particular GP120 cannot bind with this receptor because of this particular drug here. So thereby this virus cannot enter and this disease can be checked at the outset.
So is AZT effective in the present day scenario?
This is actually not AZT. AZT comes after this, but this particular drug is equally important. Actually, let me tell you, this particular drug is the first official drug which is called nucleoside inhibitor, or we call it nucleotide reverse transcriptase inhibitor, that was reported in 86. This particular drug actually is blocking that particular reverse transcriptase enzyme. So reverse transcriptase enzyme, you know, is making the viral RNA produce the DNA, and the DNA will get into the host cell. It was considered to be a very effective drug, and it includes the zidovudine, the stavudine, the didanosine. All these drugs actually were very effective for 2-3 years. But after that, what happened, as he was trying to say, that this particular drug is gradually becoming resistant because the binding site of these particular drugs are being blocked, or they are changing that binding site, so that because of this mutability of HIV, these drugs are not working. So naturally, this drug became irrelevant when it is given in single dose. Now, another group of drug actually which is coming as, we call it NNRTI or non-nucleoside reverse transcriptase inhibitor, which include this efavirenz. Efavirenz is also a very useful drug where they are binding with the reverse transcriptase and they are blocking the reverse transcriptase and not allowing the formation of DNA and its integration. These two drugs can be given in combination. That means the NRTI and the NNRTI. Coming to another group of drug, which is the raltegravir, or it is called integrase inhibitor. What is that? This drug is preventing the integration of that particular viral DNA into the host DNA. And thereby, when it is blocking it, naturally the viral DNA is left outside, so the chromosome is free. And this viral, you can see clearly here that viral DNA is given out from the nucleus because it cannot bind because of this blockage by this particular raltegravir, or it is also called integrase inhibitor. Now coming to the next group of drug, which is called protease inhibitor, because you know this HIV is producing protease enzyme which will degrade the host protein, and this protease inhibitor ideally is the ritonavir, which is binding with specific asparagine site and thereby blocking the enzyme. But the question is that I have discovered a line of drugs, but we must understand that what is the logical combination, and similarly this type of combinations was initiated, which include that SZT. Along with that, there may be sanguinavir, ritonavir added, and the dosage is 2 to 3 times a daily, but there may be some specific effect or there may be some specific side effect. Since that this side effect may include the severe lowering of the WBC, which is definitely bad. There may be another way of treating where you are adding the Videx or dideoxythymidine attached with AZT, where there will be side effect of pancreatitis. Similarly, there may be dideoxycytidine attached to sanguinavir, where there may be peripheral neuropathy. So you can see that HIV therapy, the physician has to be very careful. When I am starting a regimen, I must try to detect what type of changes are occurring in that person. Accordingly, I will modify the drug, I will reduce the toxicity of the drug, because I cannot survive without the drug. That is important. Similarly, this is another way of treating where the basic compound is protease inhibitor. Along with protease inhibitor, that is the sanguinavir, this is the basic compound. You must understand, one case where there is the NRTI as the basic compound, here the PI is the basic compound. Along with PI, we are adding AZT. But there may be side effects reduced, which include diarrhea. Similarly, there may be ritonavir, along with that AZT may be given, which also may show nausea. So, as because in the second case, the side effects are relatively low, these treatments are preferred in the present day context. Now coming to the progress of HIV development due to the therapy. So it is in 84 that HIV was discovered. The ritonavir was launched in around 1987, and then actually the number went up because so it was not that much effective. So again it was the protease inhibitor which was launched around 1995, and immediately the number came down, and along at that particular time a second drug which is NNRTI and the combination therapy started. So now you can see more or less till 2006 or beyond that we are trying to give this combination therapy. So the present day answer to HIV is combination therapy, by which the disease is not cured though, but it is kept under control. And considering the mega HART meaning the drugs are given altogether having multiple action. There may be entry inhibitor, there may be protease inhibitor, there may be NRTI, all these drugs are given at the same time. So thereby you can clearly see that the HIV binding and replication is checked. So mega HART is a new movement which was initiated in 2010 and is being followed, and effectively it has kept the HIV under control in the developing and developed world. Though in the developing world the problem is different because people are not aware of this particular disease, particularly in the rural areas.
Sir, what should be the ideal way of preventing HIV?
Actually, I am going to conclude with this particular answer. It's a good question. What we should do? You see, at the first step, there is no specific treatment with which it can be cured. So ideally, it should be prevented. So prevention is better than cure, should be followed here. So we should try to prevent this disease through reducing sexual contact, indiscriminate sexual contact, or to be little more cautious at the time of sexual contact. At the same time, there must not be needles which should be shared, which are common ways, because the HIV is progressing through blood, and when the disease is there, there should be scientific HART applied in the form of this entry inhibitor, balanced NRTI or NNRTI, and also integrase and protease inhibitors. So if we can follow this balanced regimen as suggested by the HART under the guidance of a good physician, then we can at least increase the longevity of an HIV person for 18 to 20 years, where previously people used to die in 4 to 5 years. So that is my answer, that we have to prevent the disease rather than to treat it.